Okay, so we established last lesson that ln x and e to the x are inverses of each other. So that means if you apply e to the x and then ln, you will end up where you started at x. So i.e. ln of e to the power x equals x. And similarly, if you do ln of x and then do e to the power of ln x, you will also get x. So if you think about your composite functions, if f of x is e to the x and g of x is ln x, we're basically saying that f g of x equals g f of x equals x. So g is the inverse of f, if that helps. It's composite functions that we're doing there. So you can think of them that way. You need to be able to use this to solve equations. So that's kind of really the result that we're using. This means that whatever you put in to here, it will map you back to where you started. So just to make that clear, if you do ln e of x cubed minus 1, that will equal x cubed minus 1. If you do e to the ln of, I don't know, I'm just putting something else in, I'm not overthinking about it, x over y, then that equals x over y. So it just maps you back to where you started. So, using to solve equations. So, if e to the x is equal to 5, I've started with this one. Yeah, then you can rewrite that as a logarithm, and you know, this is your power, this is your base. So log to the base e of 5 is x. But I want you to start thinking of these in terms of inverses instead. So you can take natural logarithms of both sides. After a while, you won't want to write this line in, which is why I'm doing it in a different colour. So if you take natural logs of both sides, that's using the last rule I put on the other board. And then ln e to the x is equal to x, and so x equals ln 5. So if you ln this one, you will get x. If instead of this you have 2e to the 3x equals 8, you can do a similar thing. The thing you need to be careful of is that you get e on its own before, on one side of your equation, before you do ln. So I can divide by 2, and then 3x will equal ln 4, but the logic, because there's a slight shift in logic, is that ln of e to the 3x equals ln 4. So you're taking natural logarithms of both sides, and so 3x is ln 4, and pure maths, most of the time we leave our answers in exact form, so x is a third ln 4, or ln 4 over 3. But it would be ln 4 all over 3, not ln of 4/3. So just be a little bit careful with what you're doing. I'll do one more of those. So over to here, if I've got 4e to the negative 0.1x plus 2 equals 14. And then the first thing I need to do is rearrange this to get e on its own. So I take away 2. I've kept my numbers nice. And then dividing by 3. And after a while, you'll just look at that and go, okay, negative 0.1x equals ln 3. But what you're actually doing is you're taking natural logarithms of both sides. And write that in if it helps. It's absolutely fine. I'd rather you wrote more and kept it correct and kept your understanding. And so negative 0.1x equals ln 3, and so x is equal to times it by minus 10 ln 3. So that's up in there. And then we need to do the same thing, but it's kind of going back the other way. So hang on, let me check my timing. Yeah, I should have time to do that, I think. Right, so if you have ln x equals 7, what we're going to do now is we're going to do e to the power of both sides of the equation. So you can do, again, this is the line. You might get a bit bored of writing. So e to the power of ln x equals e to the power of 7. That's fine because, like ln, exponential function is a one-to-one mapping. So if a equals b, it follows that e to the a equals e to the b. So because it's a one-to-one mapping, it's fine. You can't do that with like sine and cos and many-to-one mappings. That's not always going to be true. Right, so e to the ln x is x, and so x equals e to the power 7. But you know that because you can rewrite this as a logarithm, but it's subtle, it's just changing the shift a little bit to inverses, which will be really useful as we go through. So 3 ln 5x equals 18. Again, you need to get this ln on its own. You could pull that up as a power, but to be honest, on this one it's better to divide both sides by 3. So ln 5x equals 6. Now I've got ln by itself. I can do e to the power of both sides. Like so, and e to the power of ln 5x is 5x equals e to the power 6, and so x is 1/5 e to the 6 or e to the 6 over 5, whichever you prefer. You'll just get used to this. It's one of those things you sort of get used to and then you don't really think about it so much. I'll just do one more. So 4 ln 2x plus 1 minus 1 is 15. So I need to sort these numbers out first. So 4 ln 2x plus 1 equals 16. Divide by 4. So I've got ln by itself. And then I can undo this ln by doing e to the power of both sides of the equation. You will need this when we start doing integration. And then 2x plus 1 equals e to the power 4. And to leave that in exact form, you can literally just do e to the power 4 minus 1 over 2. Remember, it's an irrational number, but it's fine to leave it in your answers, so like pi, and like you leave your ln answers as well. So Yeah, that's more exact than writing a decimal. So if you could do the sheet, question 3, question 4, and then there'll be a few more questions on your lesson plan.